afternoon, viewers. You are welcome to B-domeduaids channel. Today, we will be looking at spherical geometry. Now, when we talk about spherical geometry, what do we mean? When we talk about spherical geometry, it has to do with measurement around the globe. Anything that has to do with sphere has to do with a circular form. So we are going to look at basically the introduction to spherical geometry today. So if, for example, this is the globe. Because the globe is spherical in shape. If, for example, this is the globe. If this is our globe, here we will have here to be north, and we have this zone to be south, and we have here to be west, and here to be east. Now I'm going to lay some foundation to help us in the solving of our latitude and longitude, because most people have been saying I should shoot video on longitude and latitude. So this introduction now will give us the basis on what to do when we get to longitude and latitude. So if this is our north, our south, our west, and our east, look and pay close attention. The line that divides the globe into two equal halves, running from the west down to the east, is what we call our equator. So this one is our equator. This is our equator. That's the line that divides the globe into two equal parts. And the equator moves around the universe or the globe. It goes around. That's why you see these imaginary lines here. So from the west running across to the east, we have the equator. And the equator is the center of the globe. Now from the north running down to the south, we also have a line that divides it running across the globe, and we call this other line Greenwich meridian. That's the line that divides the world into two equal parts, from the north running down to the south. So if we have established this Greenwich meridian now is going to serve as the reference point to our longitude, and this equator is going to serve as the reference point for our latitude. Remember, the latitudes are imaginary lines that run from the west to the east, thereby putting the equator either at the north or south above it. So all the lines that run from the west like this across to the east are our latitudes. All the lines that run like this these ones are our latitudes. Like this, they are imaginary lines. They are in a circular form, that's why I'm putting this. They run across like this. All these ones are our latitudes. Remember, this one that divides the world the globe into two equal parts, is not the latitude. This is the equator. So the equator is the reference point of the latitude. And the ones that run from the north to the south are our longitude. So these ones now are our longitude. So I'm going to establish some interesting facts. If this is our equator, that is the reference point, any angle at the equator is equal to 0. So this is our equator. The angle theta at the equator is equal to 0. Theta at the equator is equal to 0. And from here, from the equator up to the north, it varies from angle 1 to angle 90 up the globe, up to the north. And from the equator down to the south, it also varies from angle 1 to angle 90 as well. From the Greenwich meridian to the east varies from angle 1 to angle 180. And from the Greenwich meridian to the west also varies from angle 1 to angle 180. Take note of that. Very interesting. So now, if this is our equator, from this equator to the longitude, if we measure from the equator to the longitude, we are going to get the value of the radius of the earth. The radius of the earth, which is represented or denoted by capital letter R. And this is a constant value because the equator is always constant, it's not changing. So the value of the radius at the equator represents the radius of the earth, and it is always constant, and that constant is equal to 6,400 kilometers. So anywhere at all, the value of the radius from the equator to any of the longitudes is 6,400 kilometers. Now, outside the equator, if we come to this latitude, if we are going to measure the value of our R on this longitude, it's going to vary from the one we measure here, and it will vary from the one we measure here as well, because the lower you are going, the value of your radius for the latitude is reducing. That means we will call this other small r. This is the small r. That's the radius of the latitude. And remember, we say it varies. So they will give you the value for your radius of your latitude. But the value for the radius of the equator is always constant. That's why we have this. Right? So, since we have established this, we can now go ahead to start our calculation. We can now go ahead to start our calculation. But before you start any calculation, you have to learn how to locate your point on the globe. You have to learn how to locate your point on the globe. For example, what I mean by locating of a point is that if you have, for example, town A, which is equal to 40 degree north and maybe 20 degree, let's say, west, and you have point B, which is, let's say, 20 degree south and 20 degree west. How are you going to locate these two different points on your globe using the knowledge of your latitude and longitude? That's what you need to do before you can move ahead to start your calculation. So in my next video, I will shoot on how to locate your point on the globe, so that as soon as you can locate all these points on the globe, you can now forge ahead to start your calculation of longitude and latitude. That simply means I'm going to introduce what is known as the great cycle and the small cycle. So my next video I will cover the great cycle and the small cycle. I hope this video is interesting, and I hope most of you understand the introduction to longitude and latitude. So this is basically the introduction. So just study this and understand this video so that my next video you understand it better. Thank you for listening.